Good day, everyone, and welcome to today's DevOps.com webinar. We have a great topic for you. It's secure your pipeline while keeping your developers and admin happy. Hey, that's a great thing. You want to keep those folks happy. Today's webinar is sponsored by Red Hat and by Trymost Security. My name is Mitch Ashley. I'm Managing Analyst with the Accelerated Strategies Group. I'll serve as your host and moderator for the webinar. A few housekeeping items. We are recording the webinar, and we will send an email to all participants, everyone that's attending, that has a link in it to both the slides and also the recording. We are giving away 3 $50 gift cards, so be sure to stick around to the end and find out who our winners are. We have a great speaker today. I'm excited to hear the topic and also hear him talk about it. So we really encourage questions. I know that he likes to answer questions and is ready to respond to those. So just put those into the questions tab on the GoToWebinar software, and we'll get to those a little bit later. We're also doing a demo today, so I think you're kind of getting a double dip of some great stuff, presentation and demo. So let's move to our topic, secure your pipeline while keeping your developers and admins happy. It's my great pleasure to introduce to you Mark Borstein, who is CTO of Trymost Security. Mark, I think we're all ready to go. I'm going to hand it over to you.
Great, thanks, Mitch. So we're going to talk today about how do we secure our pipeline. We talk a lot about building out a pipeline to securely develop our containers and deploy them in Openshift. But today we're actually going to look at how we secure the components of the pipeline and how we automate the build out of that pipeline. There we go. So first off, really, who is Trymost Security? We were founded in 2010. And our slogan says it all, cloud native identity management. So what does that mean exactly? So small, lightweight, API driven. Yes, we deploy inside of a container. But you're really using the pieces that you need. You need a workflow engine, great. You need a virtual directory, great. You don't have to deploy everything just to get one component. We're open source. All of our infrastructure, all of our software is open source, all available on GitHub. And we've been working with Openshift since 2015, the Openshift 3.0 days. And one of the things that we're really proud of is we're consistently working with Red Hat as their certification process continues to move forward. We're in the first class of certified Red Hat containers. And then last year when Red Hat announced its first class of certified operators, we were a member of that class as well. So we've got a lot of experience working with Openshift. So when we look at DevOps pipelines in Kubernetes, it really reminds me of a Rube Goldberg machine. So if you're not familiar with the concept of a Rube Goldberg machine, it's the idea that you build a very complicated process to do something very simple. It's very meme-worthy these days. It's not unusual to see somebody post a video of one of these and say, this is Kubernetes. And the reason for that makes a lot of sense. Kubernetes is great at orchestration, orchestrating your infrastructure and providing you a way to have an API-driven infrastructure. But I think it was Kelsey Hightower who said, Kubernetes is a platform to build platforms. It's not a platform in and of itself. So if you're starting with a raw Kubernetes implementation, you still need a development system. You still need source control. You still need development orchestration, scanning, deployment, etc. And so depending on how you go about it, these systems might all come together in kind of a patchwork quilt, as opposed to rather a streamlined solution. So now let's go ahead and enter Openshift. And when I look at Openshift and what it brings to the DevOps conversation, it kind of reminds me of Lego Technic. You've got all these different gears and pieces and stuff that just looking at it, you can fit everything together in a very consistent way, a way that has interchangeable pieces, things that are consistent across environments. But the key is that it still needs to be built to match your enterprise. You always want to build your technology to match your enterprise. You don't want to have to adjust your enterprise to meet your technology. So that brings us to our next part, is what's the goal with your pipeline? You want to build something with all those Technic pieces. So here's a Corvette. If you drive, you push it around, pop the hood, you'll see that the the engines move, there are gears in there, there's stuff happening. It all just looks really nice. And that's where you want to get to with your pipeline, where as opposed to that Rube Goldberg machine, you really want to have something that's very consistent and repeatable. And that's how you're going to make everybody happy. So how do we get there? Well, if you're a developer, you just want to code. You don't want to deal with YAML, and you like Git. You have an IDE, you want to do your development in there. You're used to the ability to be able to push changes, merge, branch. You also want to have a sandbox. You might have code-ready containers running on your laptop, but you might also want to have a sandbox with a little more horsepower that's running up in the server world. Administrator, I don't know about you, but a lot of admins I know, Slack gives us a bit of a nervous tick every time you hear it. And when somebody needs access to something, you know, okay, somebody is asking you personally, hey, can I get access to this? Even if you have a ticketing system like ServiceNow or Jira in place, that kind of Shangri-La of ITIL and the idea of having that single point of contact, you know, once you're the single point of contact for something, you become the single point of contact for everything for the person. They latch onto that. So how do you get away from that? You want to make sure that it's very easy for people to do things on their own without having to talk to you. And then it comes to how do you actually authorize access to these systems? Let's check out Google and see what that has to say. Every year or so, you've got to do those audits. And if you're organized with your inbox, maybe you're just dumping emails onto someone. If you're not that organized with your inbox, like me, that can be a really painful process. So, you have more important things to do, like maintain systems. You don't want to have to be digging through that. And you don't know why they decided to do a rollout on a Friday. Nobody asked you, but you really wish they had because you would have told them not to. And so as an administrator, just because developers have all this power with APIs doesn't mean you want to let them do everything. So now security. Why is there a project called Make Coin Mining Money here? Who approved it? Why is it there? Do we know why? Who's approving access to these systems? How do we know these users should be able to get to these systems? You've got multi-factor authentication in there, right? And you've got multiple environments and you're scanning everything, right? You could show that. And so you've got all these different people with different hats. I don't have a specific slide for it, but management will probably have a perspective as well. They've got to go through their change control processes. They want to make sure that that process is being followed and there's a way to go through that audit. So we've talked a lot about DevOps. We haven't really talked about identity management. Why is identity management important to this process? And ultimately, why does it matter to you as a developer or infrastructure team? Well, there's a lot of people who will try to sell DevOps, right? Or there are a lot of jokes out there on the internet. Oh, I'm just going to go buy DevOps. I have DevOps now. But the reality is DevOps is a collection of multiple tools that get brought together. In this particular demo, in addition to Openshift, we've got Jenkins, we've got GitLab, we've got SonarQube for scanning. We don't have an image scanner in this particular process, but you're probably going to be using, hopefully going to be using an image scanner as part of your process, whether it's Anchor or Harbor or one of the other ones. Quay, I think, has built-in scanning now. You're going to probably have a GitOps system. Maybe something like Argo to be able to move your manifest source control directly into your projects. So there are lots of different pieces to this. And they're all applications, and they all have their own internal identity management needs. GitLab has users, SonarQube has admins. So there are different areas where you need to know who users are. And that becomes an identity management problem. Who has access to what? So it turns out that by answering this question, you provide a really powerful way to be able to automate the onboarding of your pipelines. In the Rube Goldberg example, functionally it might work. Operationally, it might work really well. You might be able to go from a git commit to a running container. The question is if somebody asks, how did that container get there? Can you provide a definitive step-by-step process of how that happened? And not just the step-by-step, but who was actionable on that? Who's accountable for those decisions and those different toll gates? And then finally, can you automate that repeatably? So can every single project you deploy fall within those constraints? Just starting with Kubernetes and then Openshift, that gives you the platform to do it, but you really want to be able to say, I'm getting from point A to point B in a consistent way, a reportable way, and an auditable way. So we're gonna have some fun here. We've talked a lot about how you can get to things, but we're gonna talk about how we did build something. I'm a technologist, I like to build technology. I hope everybody in the call is gonna enjoy a fun demo here. So we had a customer that asked us to build a multi-environment OpenShift proof of concept for them. They wanted to use GitLab for their source control management. They wanted to use OpenShift, and they wanted to have a multi-OpenShift environment. They also wanted to make sure that we were leveraging a lot of the power of OpenShift. They wanted to make sure that we were using the features that OpenShift provides. And we'll get into some of those features that really make for a powerful DevOps experience and made the automation much, much easier. And so the idea that we wanted to go through was really two workflows. A developer workflow for being able to onboard a project, get that project approved, and provision the various components across development and production. The ability for a developer to commit their code and have that code generate an image into the dev environment. And then finally, being able to request that an image be promoted to production, go through an approval process, and then automatically promote that image to production. And that's what we're going to demo today. We're not going to dive into the manifests themselves. Really, this particular proof of concept is focused on the images and how those images go from raw source code into a production environment. So let's look at the dev pipeline in detail here. So the first piece is to say, once I've requested access, as a developer, I'm going to go ahead and do my development, merge it into master. So at that point, we want OpenShift to check out the code, do a build. The example we're going to use today is Java. So we're going to do a Maven build. We're going to run it through a static code analysis using SonarQube, create a container, and then push it into the test environment. So this is all going to be done on merge. Developers not going to have to log in and hit any buttons to make this happen. Now, one thing I really want to point out here is the power of these last two steps, create container and push to test. The components inside of OpenShift that are really powerful here are the image streams and the deployment configs. With that, you don't have to go messing with your YAML manifests in order to update containers. OpenShift is watching its own internal container registry and looking to make sure that that those containers are updated. When they are, automatically rolling those out for you. So it's a really powerful construct. So we've done our development, we're happy, we've done all our integration testing. It's now time to push into production. How do we go about doing that? So what we'll do is, as the developer responsible, I'm going to say, all right, I'm ready to push to production. That'll kick off an approval step. Now, most enterprises have different types of approval processes. Usually some kind of stakeholder-based process where before you can push into production, all the stakeholders have to say yes. Often it's at regular intervals, unless there's an emergency that things need to get pushed out. And so the nice thing about this is this can either meld to that process or even accelerate it, because now you can automate the approval process. You can say, okay, these are the people who need to approve deployments and do it dynamically based on the project. We have a very simple approval step in this particular demo, but really the sky's the limit. The other nice thing about this process is, well, I'm going to show it off using our UI. It's all API driven. So you don't like our UI for whatever reason, go ahead and integrate it into your own portal. Excuse me. You know, it's all APIs. So integrate it with Jira, integrate it with Git, integrate it with ServiceNow, whatever your process is, call the APIs, make your life easier. So once it's all been approved, everything's being audited. Everything's being, audit trail is being generated that can then be reported on. And finally, we're gonna push that container into production. Openshift has its own internal container registry, which is great because it's all self-contained. So once we move it, the container from dev to production, that production container is there. Openshift detects that we have a new rollout, goes ahead and deploys new version of the app or the service. And you know, you go back to those three different or stakeholders: your developers, your admins, and security. You know, your developers are primarily focused on running their code. You are not going to see me use the OC command in this demo at all. I will be logged into Openshift to show you what's going on, but as a developer, I don't have to be. I'm notified when things are ready to go. As an admin, I'm not taking messages on Slack. I mean, yeah, we could do it in Slack Ops if you really wanted to, but you know, there's no manual process. I'm not even in the loop except for, you know, potentially as a stakeholder to do approvals. And then finally, from a security standpoint, I'm going to show you the audit logs that really make an audit much easier. So let's get to the fun part, the demo. So I'm going to go ahead and switch here. So the first thing I'm going to do is log into our portal. Now we're an identity management company. We're going to show you a lot of SSO. We're not going to dive too deeply into the SSO process. It's kind of table stakes when it comes to most of these systems. But real quick, here we're using a local database, but most enterprises, you're either going to be talking to AD or a cloud-based authentication service like Okta or Auth0, something like that. We'll integrate with that just fine. So I'm signed in, and here's the first thing as a developer that I think is great is all my tools in one place. I have access to everything. Everything's at my fingertips. From an admin perspective, somebody asks for help. First thing I always ask is, okay, you know, they say I need access to this, or I should already have access. Hey, go check your roles. What does it say? You're providing that at their fingertips. And this is all self-service. So the first thing I'm going to do is I'm going to go ahead and log into my Openshift Dev console. So we can see that I've got DevOps Dev there. I'm also going to log into GitLab because these are going to be the primary tools I use on a day-to-day basis. And then finally, I'm going to log into the production console so that we can follow the process as it goes. There are a lot of moving parts here because, you know, it's a pipeline. So we're going to go through each step one at a time so that we can see how it all comes together. So the first thing I'm going to want to do is I'm going to want to create a project. So when I go to create my Openshift project, a lot of things are going to happen. The first is it's going to create a bunch of objects inside, it's going to create a project inside of GitLab. It's going to create a deploy key so that Openshift is able to talk to GitLab and pull the source code. It's going to go ahead and build out a test environment. So test project, RBAC bindings, image streams, etc. It's going to build out a couple of build configs. That's our actual pipeline. It's going to create projects inside of production. It's going to create a link between production and test so that we can go ahead and move the images back and forth. That's all going to happen automatically. So I'm going to go ahead and create a new project called Greetings 11. Now, here we're just typing in the name of the source to image stream that we want to use as our builder image. But had we had a little more time on the original POC, we could have just very easily made this drop down. And we're going to do this for the demo. So I'm going to submit the request. and my email goes off and says, hey, you've got an open request. The first thing I'm going to show is my boss is giving me a hard time. Where's that greetings application? Well, here's a report. I'm enabling the user of my open request. This is who I need to go bug, the smart guy. So let's go ahead and do a quick refresh. Now you can see I've got this open approval. I'm going to give a reason for the approval. So I'm going to approve that request, give it a few seconds. We're going to see a little bit of magic happen. So we don't have greetings 11 here. If I hit refresh, there's greetings 11. That's an empty Git repo. But like I said before, we've already got a lot of our integrations there. So if I go to the repository, there's already a deploy key set up, and that's also been provisioned into Openshift. So I don't have to worry about connecting these two systems, looking at blog posts, stuff like that. Also, if I go to integrations, see there's already a webhook set up and ready to go, so that when I push into my Git repo, this is ready to go and start running. So now let's go ahead and check out our dev environment. So here is DevOps prod. So let's start with DevOps dev. And let's go to our image streams. So let's check out, we now have a project called Greetings 11 Test, and we have an image stream. So if you're not familiar with Openshift image streams, this is an abstraction layer on top of a container. It's a way to have a placeholder to say, this is the image I'm talking to. So if you're familiar at all with upstream Kubernetes or vanilla Kubernetes, depending on how you want to call it, if you want to roll out a new version of your app, you have to go into the deployment and change the image that you're pointing to. The alternative approach with Openshift is to tag your image stream to which image you want. So that way you're not making patches onto a deployment. The deployment config will say, oh, new image stream, let's go ahead and trigger that rollout. It's a really powerful construct. So now we're going to come over here and we're going to do the same thing. So this is our prod environment. And we're going to come here and we have greetings 11 prod. And again, we'll see no tag. So let's go ahead and push some code. So first thing we're going to do is we're going to check this out. All right, and we're going to go into here, Git archive. So this is a real simple Spring Boot web service. Don't really need to dive into this too much other than it's Java. So we're going to want to do some Java analysis on it. Let's go ahead and add everything. Oops. And let's push. So we've done a push. So we come back here, and we're going to see, hey, look, everything's pushed. So now at this point, let's go back here. I think this is dev. Yep. And so this particular customer wanted to do everything with Jenkins and wanted to have one single Jenkins as opposed to a different Jenkins per namespace. So you see we have a bunch of different image streams. We'll come down here. We've got multiple build configs, and here's our greetings 11 build config and the pipeline. So it's really a two-step process. We'll see that there's a build running somewhere. Here we go. So build pipeline is running. So what this is doing is it's checking out the code, like we said, doing a build, pushing it into SonarQube, and then finally, everything looks good. Let's go ahead and kick off an S2I image build so we have a container and push it into the test environment. So this is running, gonna take a few minutes. So while that's going, I'm gonna switch gears a little bit here to the audit side of the world where we talked about the ability to track what was happening. So I come here, I come to Audit Reports, and we can look at our completed approvals. And so this is a lot of the power here, is we can see the application was created, why it was created, who did the approval. Now, of course, these approvals can have multiple steps, but that gives you an audit log. Also, if we want to look at what actually was changed, you know, we're not just auditing things that get users that get provisioned. We're providing an audit trail of all the different pieces that get created. So this particular report doesn't break it out by the target, but the data's in there to be able to show it. So you can see we're creating image streams, we're creating services, we're creating role bindings, we're creating the deployment configs. Inside of GitLab, we're creating the projects. So now when you go to, when somebody says, how did these things all get there? You now have something to audit that against. I've actually got a customer that is looking at using like Gatekeeper, which is OPA plus audit capabilities, to be able to say, you know what, if there is something in my cluster that is not in this database, that needs to get flagged, because that means it wasn't tied to an actual approval process. So let's go ahead and come back here, and we can see that the code analysis is done. So let's go ahead and check that out. Let's come back to our portal. Let's go check out SonarQube. I can log in here, because of course I can. And we can see there's greeting 11, it passed. Now these are just the standard SonarQube rules. You know, every enterprise is going to have its own rules. That's great. The point is to show that there's actually a process to be able to handle that. And so now we can see that the pipeline is finished, and it says that the image has been tagged to test. So if we come back to our greetings 11 test, we go to our image stream, we're going to see that now, instead of it being an empty image stream, we actually have a tagged image. So now I'm able to deploy my manifest, however we're going to go about that process, do our testing, make changes, recommit. Everything just keeps getting updated inside of our test environment. At this point, we're happy. We're ready to deploy into production. So as a developer, or whoever's responsible for this process, you'll also see here, I'm back in production, we don't have a tag. So now, as a developer, I want to go ahead and I want to deploy into production. So I'm going to click on Deploy Project to Production. You'll see we have a few projects here. This is a dynamic list. So as we add new projects, this gets added to the list. So you don't have to go through and add new workflows for every single project. It's all dynamic. You can also drive things based on it. So you'll see that every project is not listed here. That's because we've said, you know what, only give me projects with a label that says it was generated by OpenUnison. So we don't want just anybody to deploy anything. And so at this point, I can pick which project I want to deploy. And add that to my cart, give a reason, submit the request. So at this point, the request to deploy to production has been made. If I go over here to my open approvals, you can see there's a pending production deployment, and it's waiting on this dude, Mark Borstein. So at this point, this is where the enterprise change management process kicks in. You know, does this kick off a ticket in Jira that needs to get approved? Does this kick off a ServiceNow ticket? Really doesn't matter, because it's all APIs. That's the great part of this. So now, since I'm also the admin, I'll go ahead and do a quick refresh. There's my approval. So I'm going to review this. I'm going to say, yep, everybody's signed off. Now, let's go here to production. So this is production. Here's my image stream. You can see here I don't have any tags yet. Now I'm going to go ahead, I'm going to approve that request. And then we're going to see, look at that. We already have the tag is in there. And if we look at that SHA, you're going to see B4690 ends in 11C. Let's go back to dev. B4690 ends in 11C. So now you have that automated process. I haven't opened up a command line window for anything except Git. No OC commands. And quite frankly, had I not been trying to demo the process, I wouldn't have even had to have logged into Openshift. And then finally, we want to come back here again with the reports. We can check out the approvals. Go all the way to the bottom. So we can see it was an approved production deployment. Who did the approvals? Now, of course, if you have multiple stages of approvals or you have multiple stakeholders that need approving, they'll all get listed here. So you have that information. This data is stored in a relational database, does not require our specific reporting software. Our stuff is real simple. It's just SQL statements. Most of our customers, once they get beyond kind of the pre-canned reports, they'll often say, we'll just hook it up to whatever our reporting engine is of choice, because all of the data is documented. It's all schema marked, so pretty much anything will be able to pull it right in and know how the relationships are. And then finally, if we go to the change log for period, same data cut a different way, we can see that we had a image stream tag for greetings 11 latest that was replaced at this date. So that's the workflow actually showing what changed as part of the process. So we've gone through that whole life cycle of requesting that a project get created, making sure that it's a valid project through an approval process, provisioning all the different pieces that are needed across your multiple clusters in order to get that container deployed. As a developer, being able to commit the resources, and then going through the workflow of building it, generating a container, and getting approval into production. So with that, I think let's come back here. So we did the demo. And like I said, we're an open source company. Everything we do is open source. So the source code for this implementation is on GitHub. It is not meant as a turnkey solution. This was a proof of concept that we built for a customer for their particular requirements. I will tell you, we have a couple of other customers doing doing something similar. And even within the same industry, they have really particular asks. Some customers don't want us to manage any of the authorizations. They want to be able to assert who has access based on Active Directory groups. They don't want us providing any kind of request management. We've got other customers who, for each individual project, want to be able to control who has access. Some are using templates, and they're saying, you know what, just go ahead and copy all the code into Git when it first launches. So there's a lot of capabilities there. But like I said, all of the code for the demo that you saw today is sitting in GitHub. And so please feel free to go there, try it out, poke through it, pull requests, always welcome. So with that, Mitch, do we have any questions?
Yeah, we do, Mark. We've got some great questions lined up. Several questions around what does it take to set up a proof of concept? So maybe, obviously, we're an open source product like yours, which is fantastic. Can you talk a little bit about, you showed how to get things from GitHub. What does it take just to set this up?
Sure. So I'm actually going to go ahead and come back here. Whoops. And I'm going to click on that link. So the setup process itself is actually pretty straightforward. This particular one was designed to run in AWS, so we provide the commands that we use. But really where things get great is, I'm going to skip down here to step 5. So we're built on top of an operator. And what that means is that we've taken all of the knowledge of what it takes to create an open unison deployment. We've baked it into code. And then Red Hat said, okay, we're going to have a certified set of operators that have been curated that meet our exacting standards for what needs to go in there. And you're going to have to provide some metadata for it. And so we went through that process, like we said. And so the great part about it is once you have Openshift up and running and you have these other tools deployed, setting up Open Unison is actually really simple. You create a secret. That secret has, secret information in it. You don't want to put passwords into anything that you'd be willing to check into, like GitHub. And then you create a Open Unison object. And so this Open Unison object, I won't dive into all the details, but it has all the information I need to run Open Unison, certificates that are needed, configuration options, etc. And then finally, you deploy the operator from Operator Hub. So if we come over here to Openshift and we go to operators, go to Operator Hub, find there we are. Everything's right there for you. So you can go ahead and run your install. The image itself is built onto Red Hat's Universal Base Image. I think it's running 8.0 now. And the operator does all the hard work for you, in conjunction with Openshift. We're generating Openshift native objects. So this is not, upstream Kubernetes being jammed into Openshift. We generate image streams, we generate builds, we generate build configs. And so we're doing it in not just a Kubernetes native way, but also an Openshift native way. When I set up this particular demo, when I brushed it off, because we had done this for a customer a little while ago, probably about 85% of the time was setting up multiple OpenShift clusters, SonarQube, GitLab, all the different pieces. The Open Unison setup itself took like 15 minutes. So it's a very quick deploy.
Great. That actually answers another question some folks had, was just kind of what time commitment does it take to get the initial Open Unison up and running? Another question that's come up here is people are interested in what sort of the business model, the cost model is around this. Initially, obviously with open source and being able to download it off GitHub, that's all free to use, et cetera. But where does this kind of turn into a paid for product, and what do those look like? You don't have to name cost, but just gives an idea of the model, how it works.
Sure. So it's we're actually very open about our costs, at least as of today. You're looking at $30 per user per year. And so that gets you support. We're not open core, so there's no difference between our paid version and our unpaid version. The difference is how you interact with Trymost security for help. If you're using the open source version, we're happy to respond to GitHub issues. There's no SLA, you've got to put everything in there. There's no private messaging, etc. Once you go up to the production, or excuse me, not the production, the paid for commercial version, get private support ticketing with us, 24/7 support. We also offer help with potentially monitoring, although most of our OpenShift customers are really happy to use their own built-in monitoring. And so it provides you with that safety blanket that says, yes, somebody's keeping an eye on things. Also, when you're a paid customer, features that you might need get moved to the front of the line. So customer says, hey, we really need GitHub support as opposed to GitLab support. Well, if you're paying, that feature moves to the front of the line.
Excellent, great. Well, that keeps it simple then. That's fantastic. Can you talk a little bit about secrets management, identity management system, third-party products that folks obviously may have already invested in, and how you might work with something like that?
Sure, and that's pretty common, especially in enterprises. You might have deployed OpenShift and you have Okta or Auth or some of these cloud-based authentication solutions for your enterprise. you might be running Active Directory Federation services. Pretty much all of our customers have something else in place. And so where we really come in and where our value is in making those things all work together. We very rarely come in and someone says, you know, I don't have an SSO solution in place. They usually say, I have an SSO solution, but I don't have the glue to get from can the user get in to why should the user get in? And that's really where the rubber hits the road for us.
Okay, excellent. Yeah, I imagine most folks do have some sort of directory and access control, credentials management. So another question is, we have a very unique network environment. Is Tremolo Open Unison capable of working with disparate systems?
Yeah, and that's our bread and butter. I mean, you just saw, you know, we talked to GitLab, SonarQube. You know, if it's got an API, we can talk to it. Very small, lightweight footprints to be able to integrate new systems. Usually within 24 hours, we can get a new system integrated.
Okay. Would you elaborate more on how security is implemented other than using Active Directory, having the approval process? There's actually a previous question too about what exactly is Open Unison doing in that approval process.
Sure. So we have our own workflow language inside of Open Unison. It's a very simplified, streamlined language. It's only got like 5 or 6 built-in tasks, and then everything else is custom implemented using Java. And so the idea was we originally looked at you know, how do we build a workflow language? You know, do we want to use some of the standards that are out there like BPL or BPM, and decided that we didn't want to go that route because those languages are as much for making a visual system as they are for code. And what we found was if you tried to compare 2 of those, you couldn't, because once something moved, all of the metadata about where things were located just went out the window. So that was one issue. Another reason why we decided to go with our own is our workflows can run in one of 2 modes. They can either run in what's called a just-in-time mode or in an asynchronous mode. And we wanted to have the same language for both. So as an example, I'm logged in here to prod. Let's come over back to dev. And I have a sandbox for my user. That sandbox was created just in time the first time I logged in to Open Unison using my credentials, because this particular customer said, you know, we want everybody to have their own sandbox. For a just-in-time workflow, you don't want that to be asynchronous. You want that to happen immediately. And then if something goes wrong, you know, provide the user feedback. Whereas with the workflows I showed today with approvals, you want it to be very asynchronous, highly scalable, reliable. And so what we're doing in the background is every single message or every single task in our workflow becomes a encrypted message on a queue. That makes the system very, very scalable. So here we only have 1 instance, but you can scale this out from 1 to 1 million, doesn't really matter. And so as messages get on the queue, they get encrypted before they go on the queue. So even if you're using a message queue that encrypts messages, somebody gets that message, they still need the keys to decrypt it. So we're encrypting every message that goes on the queue. Because there's sensitive information there. There could be passwords in there, could be authorization information in there. You want to make sure that that doesn't get tampered with. And then every message gets handled. And if you know, a database or something goes down, goes into the dead letter queue, they can then be retried. So it gives capabilities around that.
Okay, great. We will kind of go step back just a moment to the secrets topic. What happens to the secrets created in the flow? Where are they stored? How are they rotated, et cetera? How do you do secrets management with that?
So our tool is not specifically a secrets management solution. We want to rely on the infrastructure to provide secrets management, because you might have Vault or one of the other secrets managers. So we try to stay very specifically to Kubernetes secrets. And so the way that the process works is, if I come back to GitHub, so we had a secret up here that we created. This secret could be generated by Vault, right? Because Vault has a built-in secret injection process. This secret then gets consumed by the operator. The operator takes that secret, generates a secret package, I guess is the best way to call it, which is then created and then accessed by OpenUnison's pod. So that makes it very easy for you to be able to plug in external secret management into your Openshift cluster and let us leverage that, as opposed to us trying to reinvent the wheel and build our own secret management solution.
Good, good. I'm glad we cleared that up. That's a super important topic. This may tie into the same thing, but I just want to clarify this question. What are the different levels of security, secure practices that are implemented? Is that all managed through directory and secret management system, or the privileges within Kubernetes, or do you also manage your own sets of privileges?
So we don't have our own built-in privileges. We're an orchestrator. So we can have our own privileges. You can design that in, but ultimately it depends on how you want to handle it. So like when we talked about here with different aspects of your pipeline, being different applications, they all have their own permissions. And so instead of us trying to replicate those permissions and then push it out, we just work with their permissions directly. We just work directly with that API, and then your workflows really define who has access to what through those permissions. So it makes for a very lightweight approach. You're not building what folks back in the day might have called a meta directory, where you sync everything in and then sync it out. It also makes it so that you don't have to worry about how you're handling things like mapping a business role to individual group. That all happens at the individual target layer, and so it's transparent to you in your process. So that's one layer of security. Transport layer security, everything gets encrypted over the wire. We make it very easy for you to be able to integrate external certificates into the process. It goes straight into your CR, which we're kind of showing off here, being able to handle that. And then data at rest, again, everything's encrypted. So the encryption process, everything's encrypted inside the database. Workflows especially are encrypted inside the database. Everything that goes over the wire is encrypted, messages are encrypted. And also, when we come back here to the request process, I'll go ahead and log back in. So we come in here to the request process and we say deploy to production. That's dynamic. You might have things inside of those workflows that are driving your authorization process dynamically. That's now sitting in my browser. You don't want me as the user to be able to mess with that. So that's encrypted as well and only allowed for a certain amount of time. We encrypt everything. I'd encrypt my dog if I could get away with it. And so I think we've got a pretty good security profile as these things go. Most of our customers, when they do their scans or whatnot, the biggest questions are, hey, can you enable HSTS, or let's make sure that the cookies are HTTP only or whatnot. So we take a lot of time thinking about how we handle encryption and how we handle that security. And then finally, from a workflow standpoint, workflows are immutable, cannot be changed with one exception. So the workflow itself is stored as a encrypted object in the database while it's in process, and the data around it is in the database. And so if somebody tries to, say, approve a request, because it's a documented API, so if somebody tries to approve a request that they are not authorized to approve, not only will it fail, the folks who are authorized to will get notified that failed. So that'll set off alarm bells. So we're trying to think about it from different angles and different approaches.
Good. Question about standards. Are you standards based? I know you talked about standards in relationship to the workflow, I think earlier, by process flow, but talk about standards.
Yeah, we love standards. If you talk about authentication, OpenID Connect and SAML 2 will work with OpenID Connect, SAML 2, GitHub, which is a little off standard. As an integration product, we pride ourselves on being able to integrate with stuff that's kind of standard, not just standard. So like I said, GitHub authentication, the 25 different variants of OAuth authentication out there. When it comes to APIs that we integrate with from a provisioning standpoint, Openshift specific APIs, Kubernetes APIs, databases, directories, LDAP, Active Directory. We integrate with Mongo. So pretty much every standard out there. We make sure that we're keeping up on which types of key sizes are important to use. You saw that we're storing a password. That's, I always get this one wrong, PBKS2, I think, with like 20 or 30,000 iterations and 64 byte salts. So we're staying on top of those standards as they come out.
Okay, good. Maybe a little less technical question. The question is, help me understand the time savings you mentioned earlier to implement this. You're talking about months, weeks, what kind of level of savings are we talking?
Yeah, most of our customers are usually up and running in less than a week, to be honest. They might get an initial POC up and running in a day or so, and then they'll say, well, this doesn't really match our workflow. And so at that point it becomes, okay, well, let's do some coding, let's make some changes, and it becomes, your typical iterative development process. But you don't need to have a kung fu, black belt in identity management to figure the system out. It's Java development.
Very good. In your client base, what verticals are you talking about? What kind of industries do you work with?
So we've got local government here in the US. We have financial services, both here and across the pond in the UK, and also US federal government customers.
Okay, great. Let's see here. Another question about sort of your business model? What's involved with the annual support? What do people get for that?
So they get direct line on support, so they get a private login to be able to do support. They can submit questions, without having it be in the public eye. They get an SLA, so you support that P1 ticket, we're responding in an hour. So that becomes real important for the compliance folks to say, yep, we're covering our bases there. And then you get priority on support or priority on new features. When you buy a user license, we don't care how many ways you use that user, how many applications are integrated with that user. If one user is hooked up to 4 OpenShift clusters, 3 Jenkins instances, and a GitLab and a pear tree, you're still paying one license cost.
Great, very good. I think that kind of wraps up our questions. We've pretty much exhausted all the things in the queue. There's a lot of questions. You've done a great job with that. Well, thank you. That's been wonderful. Appreciate both the presentation and the demo. I think that really made it very clear, visual to see it in action and how things work. So thank you very much, Mark.
Thanks, Mitch.
You bet. And thanks to our audience for the great questions too. Well, let's, as we do a little bit of housekeeping here, kind of wrap things up before the top of the hour, we want to announce our 3 $50 gift card winners. The 3 people are P. Scully, V. Fernandez, and B. Nentz. so we don't give away the whole name. So you got a little bit of privacy there. So we'll get a hold of each of you, let you know how we'll get those cards to you. So just a reminder that our webinar is recorded. We'll be sending out an email with links to the slides and the recording. And also it will be available on demand on the devops.com website. And be sure to check out the site too, because there's lots of great things, Red Hat and other great webinars that are coming up real soon on security, on DevOps, containers, all kinds of great topics. Well, please thank me in joining Mark Borstein, who's CTO with Trymost Security, for the wonderful presentation and demo today. We'd like to thank you, your audience. You know, you've spent near part of an hour with us, and we know your time is super valuable, and we're honored that you spend it with us. It's been my great pleasure hosting the webinar for you. Have a great day and be careful out there.